Welcome. In this video, we're going to continue Unit 2. Let's use technology to find 2 to the 14th. I already have GeoGebra up, so I'm going to type in 2 to the 14th power. So 2 to the 14th power is equal to 16,384. Now for part B, let's simplify 2 to the negative 14th. So we're going to write our answer as a fraction. For that, we need to recall that if you have a to the negative x power, this is equal to 1 over a to the x power. So in order to make this exponent that was negative into a positive, we move the entire piece, so the entire quantity of a to the x, into the denominator. Okay, so now let's look at part B. Using this information, we can write this as 2 to the negative 14th power is equal to 1 over 2 to the 14th power, or 1 over 16,384. Now let's look at part C. Part C is assuming you're using some, old device like a TI calculator, which unfortunately you will probably have to use in most classes. Let's look at what this looks like on GeoGebra. So on GeoGebra, if I type in 2 to the negative 14th power, 14, there are a few options. If you notice, it gives me the answer we had for part B. It also gives me the approximate answer. So let's use this to quickly compare what other calculators will get you, what this actually means, and how to rewrite it like you see it here in GeoGebra. First, let's talk about old school calculator notation. So old calculator notation. You would get something like 6 point, and I'm not going to use all these decimal places, so how about I just stop here? 6.1035 e to the negative 5. And this e really bothers me. It's not very hard to typeset the number 10 and an exponent, but for a lot of calculators, apparently even modern old calculators, it is. What this means is actually scientific notation. So the 6.1035 stays the same, but instead of e, we write times 10, and then this negative 5 becomes our exponent there. So every time you see this e on an old school calculator, replace it with a times 10 and make the number afterwards the exponent. Okay, so now let's talk about how did GeoGebra get this approximate answer? Because there's a bunch of zeros in a decimal place. Well, that's what this is telling you here. That's telling you that we're multiplying times 10 to the negative 5th. So we're moving our exponent over 1, 2, 3, 4, 5 times. So what would that look like? So here's where my decimal started. And I'm going to move this 5 times. And since it's negative, we move left. 1, 2, 3, 4, 5. So my decimal would now be here. And we'd have 1, 2, 3, 4 zeros, just like GeoGebra did here, before the 6. So this is old school calculator notation. This is scientific notation. And this is decimal notation. And if you happen to use GeoGebra, which if you take any of my classes in the future, you will always be allowed to use in class anytime, you can have the exact answer or the approximate answer. Let's continue. Problem 2. Without technology, complete the table and create a graph for f of x equals 3 times 2 to the x power. So they started the first example for you. And what they did here on this first example is they computed, or the original author of this document computed f evaluated at x equals negative 3. So you get 3 times 2. And instead of putting an x here, you evaluate by putting the negative 3 in for the exponent. And that looks like a negative 8. So there, now I fixed it. And that's the same as 3 times 1 over 2 cubed, which is the same thing as 3 times 1 over 8, which is 3 over 8. All right, so let's do this again. I will do this one in green. F of negative 2 is equal to 3 times 2 to the negative 2 power, which is equal to 3 times 1 over 2 squared. 2 squared is 4, so we have 3 times 1 over 4, or 3/4. I'm going to do this one more time using purple. F of negative 1 is equal to 3 times 2 to the negative 1 is equal to 3 times 1 over 2, or 3/2. Please pause this video now and attempt the rest of these problems independently. Now that you've paused this video, you should have filled in 3, 6, and 12. Let's graph this. First, we want to start with an axis, and I think going all the way up to 12 might be a little tough, especially since I want to be able to show values like 3/4. So I'm going to go to 6, and I'm going to start my horizontal axis on the bottom. And normally I wouldn't show this, and I would fast forward to this, but it's important to see how you can scale an axis when you're drawing things manually. And then I'm going to make sure I go out to -3, so I want this to be -3 here. Let's say here. I want to have a -2, -1, so here's 0. That should be where my y-axis lives, right there. And this is 1, 2, 3, 4, 5. Now we're definitely not going to make it all the way out to 5. We're going to make it out to 1 at best. But it's nice to have all these values. And I'm going to go ahead really quick and hide this just so I can show this bottom of the axis a little better. There we are. That is definitely a better view. So I have -3, -2, -1, 1, 2, 3, 4, 5. Now, since I do want to show 3/4, I'm not going to make this 1, 2, 3, because that would be really crowded in. Instead, I'm going to say every 1, 2, 3, 4 units, this is 1. So 1, 2, 3, 4 blocks, I get 1. 1, 2, 3, 4, another 4 blocks, I get 2, and so on. All right, so let's plot this first point to the very left. So 3/8. 4/8 is 1/2, so we're a little bit below 1/2. So I'm going to make a dot right about there. So again, if this is 1/4, this is 1/2 right here. Now at -2, we're at 3/4, so I should be up 3 little boxes. At -1, it's 3/2, which is 1.5, so that's here. At x equals 0, we are at y equals 3. At x equals 1, we go all the way up to 6. And now I can connect the dots. So that is what f of x looks like. And as a reminder, this is f of x equals 3 times 2 to the x power. Next, what is the y-intercept of the graph? Well, that y-intercept is right here. The y-intercept is at 0, 3. Now, why does this graph not have any x-intercepts? And we'll get back to this second question. So this is assuming that you can tell this graph has this kind of behavior. That is, it gets closer and closer to the x-axis without ever crossing. Well, let's think about it. Let's try some really small numbers. And what really small numbers live out here? I can say somewhere out here is a -100, -1,000, even -1 million. So how about we try -100? So f of -100 is going to equal 2 to the -100 power. I forgot to multiply by 3. There it is. And we'll end up with 3/2 to the 100 power. I have a positive divided by a positive, so that's still positive. Okay, no negative numbers yet. Let's see, what about f of -1 million? Well, this is 3 times 2 to the -1 million, which is 3/2 to the 1 million power. So these values are getting closer and closer to 0, but never actually reaching 0. This tells me that is x approaches -infinity, f of x approaches 0. Let's create a table of values to show or to estimate the solutions to each of the following. And already off the bat, I'm going to say try this one independently. And in GeoGebra, I'm going to go ahead and type in y equals 3 times 2 to the x power. And I have a nice little graph that I am rearranging. There it is. And my table is blank when I touch a table icon. So let's go back to the calculator and touch those 3 dots next to y equals 3 times 2 to the x power. Table of values. And I'm going to say specify my starting value at -5. I'm going to go to +5, and I'm going to step by ones just to get an idea of what's happening. And what's lovely here is GeoGebra will show you all these points. Isn't that great? Now what we can see is somewhere between -3 and -2, we have +1/2. So somewhere between -3 over here and -2, 1/2 will be our y output. Visually this makes sense, but I'm trying to avoid using the graph since this question specifically asked to use a table. But visually we can see at -3 here, we're a little bit below 1/2, but at -2 we're above 1/2. So let's redo our table. So I'm going to tap this ... and go remove column to clear my table. And then I'm going to create a new table of values. This time I'm going to start at -3. I'm going to go to -2 only. And I'm going to make my steps 0.05. And now I'm getting a better look. And I can see I'm approaching +1/2. Oh, and there it is. Somewhere between -2.6 and -2.55, I have -2.5. Let me make this table a little bit better defined. So let's remove this column, make our table of values, and go from -3 to -2. And step by 0.01. Okay, wonderful. Now let's see how close we can get to +1/2. Oh, I see it right here at -2.56. Oh, actually even closer, never mind, -2.58 right there. We're pretty close to +1/2. So there's the +1/2. There is -2.58, and that just happens to be our closest value. So here we can see our table, and right here is our approximate answer. So x is approximately -2.58. Okay, let's do the same thing, but now let's do this for part C. So there's my original function. I made sure to clear the table already. So ... table of values, and 150. Let me think. I'm going to say my ending point, let's make it 10, and let's go by ones. And I just picked that because I just want to get an idea of what's happening to this function. And already I think 10 was too high, because right away I see between 5 and 6 we'll hit 150. And I don't quite know where between 5 and 6, so I'm going to make this table a little grittier. And let's remove this column. And let's go table of values. This time I'm going to start at 5, I'm going to end at 6, and I'm going to use steps, really small steps, 0.01. That way I don't have to do this more than once. And let's see, where are we getting to 150? So far I'm in the 100 and teens, 120s, 30s. Oh, I see it coming up right here. So I'm going to estimate that right at about 5.65, maybe a little bit closer to 5.64. So let's just write at approximately 5.65. So at about 5.64, 5.65, we hit 150. And if we want to see this visually, which is not what the problem called for, but it's never a bad idea to look at things if you can. So that thick line is composed of all of the points that I want. And let me zoom in real close. So I think somewhere about here, either this point or this point, and actually I think 5.64 is probably a little bit closer. So again, there's the pasted table, and I'm going to go as 5.64 as my approximation. Finally, we can also use technology to find precise solutions to each of these equations. Namely, the idea is we want to graph two equations. So if I wanted to solve this, I would graph y equals 3 times 2 to the x and y equals 150. And in fact, I'm going to have you solve this, and I'm going to have you solve. So let's do both of them, and let's start with this on the left. Let's figure out where exactly we get to 1/2. And remember, our original estimate, we said x is approximately negative 2.58 for this one, and we said x is approximately 5.64 for this one. So open up GeoGebra again. And on your graph, you don't want to create a table of values. On the second line for input, type in y equals 0.5 and go ahead and hit enter. And you'll see this new blue line pop up, and now we can adjust our graph to kind of see where they intersect. And actually, let me stretch. There we go. And that point right there is the intersection, and I just had to touch it to bring it up. And it's negative 2.584, so our approximation was pretty good. I think that's to 15 decimal places. I hope I wrote them out all correctly. In general, I probably will never have you round to more than like 4 or 5. Okay, let's do the same thing for 150. So we can do this two ways. I can go ahead and type in y equals 150, or I can touch here next to my G and erase that 0.5 and type in 150. And that will move my blue line to a new place. So now I need to zoom my graph out again. And there is 150. And there's that intersection, 5.64. Again, we were correct with our table. And again, this is to 15 decimal places. So personally, I think using the more modern technology like GeoGebra is a better bet, but a lot of instructors will probably still have you use TI calculators for exams just because they're easier to lock down. If you ever take my class in the future, I let you use your phone with GeoGebra in class on exams and quizzes. And it is for reasons such as this. There's no reason to have to go through these lengthy steps to figure out these intersections. I hope this video was helpful.